All right, this is chapter 3, homework number 2. Let's start with 3-37. Examine the figure graphed on the right, over here on these axes. What happens when you rotate this figure about the origin 90 degrees? Okay, so if we spin it 90 degrees, this little tip comes over to here. This one goes to here. The one that was here originally comes down here. And I hope you can see that 90 degrees, it looks the same. Or it lines up with original. All right, now 45 degrees, so 90 is good. 45 degrees is going to be half of 90. Let's look at 45 degrees. So let's say we started here and then we rotated it halfway to the x-axis. So this little point comes here. All right, and the point that was here originally moves down to here. And this point here that was here originally moves to here, and so on and so forth. So 45 degrees, same answer. Okay, try 180. Okay, and by what other angle? And what shape will stay the same no matter how many degrees it's rotated? So I'll let you answer B. Give me another angle that you can rotate it so it doesn't appear to change. Try a multiple of 90. And then how about C? What shape will stay the same no matter how many degrees it's rotated? And that's a circle. Because if you rotate a circle around the center, it's still a circle. It's still going to look the same. There's no pointy, jagged edges. 345. Plot the following points on graph paper and connect them in the order given. A is -3, 4. B is 1, 6. So right 1 up 6. Make sure you're labeling the point with the letter. C is 5, -2. So that tells you to go right 5 and then down to, that's C. D is 1, -4. So go right 1, go down 4 from the origin. Right 1, down 4. Connect them in their order they're given. So connect A to B, B to C, C to D. And then you can kind of see that if you go back to A, this is a rectangle. A crooked rectangle. All right, if ABCD is rotated 90 degrees clockwise about the origin, so here is where you draw your plus sign. What are the coordinates of the vertices of A prime, B prime, C prime, D prime? All right, so if we do a 90-degree rotation, it's clockwise, so we're going this way. I'm going to write down the shortcut. This is the one from class, but you can also do this with trace paper. So B comes down here. This is B prime. All right, so B prime has coordinates of 6, -1. A goes to here. That's A prime. Make sure you put the prime. Again, use trace paper. So A has coordinates 4, 3. And then let's try to figure out our shortcut. -3, 4 became 4, +3. So the X and the Y switch. B started as 1, 6 and became 6, 1. The X and the Y switched, but we noticed that for A, the -3 became +3. And then for B, the +1 became -1. So when we switch the coordinates, we should also change the sign. This becomes -1, this goes from negative to positive. Okay, you can finish the rest. Make sure you connect it to form a new shape. And somewhere around here are the other points, C and D. On graph paper, graph each of the lines below on the same set of axes. I'll do A and B, and then we'll figure out what the relationship between A and B is. Start with A. This has a starting point of 4. So you put a dot on the y-axis at 4, and then the slope is 1 over 3. Up 1 over 3. It's positive, so up 1 over 3, and you put a new point. B we'll do in a different color, red. It has a starting point of positive 4, same starting point, but this time the slope is negative 3. It's a whole number, put it over 1. So that's down 3 over 1. Negative 3 over 1 means go down 3, then go to the right by 1. So go down 3 over 1, down 3 over 1. All right. What is the relationship between A and B? A and B are perpendicular. How do I know? Because their slopes, which are 1 over 3 and negative 3 over 1. So A and B are perpendicular because their slopes, which are 1 over 3 and negative 3 over 1, let's see their opposite sign. And reciprocal. Reciprocal means flip, upside down. What this does is this causes them to meet at 90 degrees. So because the slopes are like this, this causes them to meet at 90 degrees. And i.e., if they meet at 90 degrees, they are perpendicular. Okay? So that's part 1. Part 2 is graph C. What about B and C? What's the relationship? 357. When solving x over 6 equal to 5 over 2 for x, Nathan noticed that x is divided by 6. What can he do to both sides of the equation to get x alone? Well, to undo division, multiply. So we have x divided by 6 equals, so that's the answer for A. What can you do to both sides to get x alone? To undo the division, multiply, and we're going to multiply by 6. If it's divided by 6, we'll multiply by 6 to cancel out the division, right? Because division is the opposite of multiplication. So x divided by 6 equals 5 over 2. Now, the opposite of divide is multiply, so let's multiply the left side by 6. But that also means I need to multiply the right side by 6. And remember, 6 is the same as 6 over 1. So this is going to be 6 times x, which is 6x, over 1 times 6, which is just 6. And that's equal to 6 times 5, which is 30, over 1 times 2, that's going to be 2. Now, 6x divided by 6, that forms a giant 1. 6 divided by 6 is 1. So that's just 1x. Or actually, that's just x. And then 30 divided by 2 is 15. That's it. 3-60. Read the math in those box about polygons in lesson 3.1.2. At right is a diagram of a regular hexagon with center C. Copy this figure on your paper, then complete the problems below. Well, I guess we don't have to do that since it's a worksheet. But we do need to complete the problems below. Draw the result of rotating the hexagon about its center 180 degrees. So if we go around the world 360, one full rotation, then this point comes all the way back to where it started. So if we're going 180, it says, right, because it says draw the result of rotating the hexagon about its center 180, then this point will come over to here. This red point will go all the way around to the opposite side, and this green point will go all the way around to the opposite side. Explain what happens. So if you connect them, it's still the same hexagon. Hexagon is still the same. It looks the same. And the only thing that changes is that it's upside down. Right? It's upside down. But you can't even tell. You can't even tell by looking at it. So we rotated it 180 degrees, but you can't really tell because everything lines up again and it looks the same. This is called rotational symmetry. When you can rotate it, but you can't tell you rotated it because everything lines up again. Okay, I'll let you work on B. For C, does a regular hexagon have any other lines of symmetry? That is, are there any other lines you could fold across so both halves of the hexagon will match up? Just recall that. Recall in your brains that number of sides equals number of lines of symmetry. This word regular, what that means is it means all sides are equal length. Okay, so that's one line of symmetry, and recall that the number of sides of a shape is equal to the number of lines of symmetry for a regular shape, or for all shapes with all sides are equal. So we'll let you figure out how many more lines of symmetry does this hexagon have. 367. The diagram at the right represents only half of a shape that has the graph of y equals 1 as a line of symmetry. Draw the completed shape on your paper and label the coordinates of the missing vertices. Okay, so let's label these. This is 1, 1. This is 1, 2, 3, 3. This is 5, 1, and then this is 7, 3. Y equals 1, that is the horizontal line that hits the y-axis at 1. It's the horizontal line that hits the y-axis at 1. So we need to reflect the shape across this line, a mirror image. So draw a mirror image. That's a mirror image, right? Okay, so I'll let you label these coordinates. What are the new coordinates? Oops, that's not right. Make sure you label them. So key point there is, what is it? Line of symmetry. That is like a reflection or mirror image. On graph paper, 3-69, graph the line through the point 0, -2 with a slope of 4/3. That's up 4/3. Done. It has that point, 0, -2, and it goes up 4/3. Now let's translate the graph of the line up 4 units and to the right 3 units. So one way you can do this is, let's take this point and move it up 1, 2, 3, 4, and to the right 1, 2, 3. And then let's take this other point underneath here, the red one, move it up 4/3. Let's take this point up 4/3. And you can see that the line is the same. It lines back up with itself because the translation is just the slope. Mine is the same because the translation is just the slope. So we're supposed to write the equation for the resulting line. That's y equals mx plus b. And we skipped a, which is write the equation of the original line. So let's start with b. The equation of this new line is y equals, the starting value is -2. This is the y-intercept. And here's our slope. So y equals 4 over 3x minus 2. This is the same as the original line, y equals 4 over 3x minus 2. So I know that I did that a little bit out of order, sorry. The original line has that equation. We translated the line, but it turns out it's the same, so the equation is the same as in part A and part B. Looks like we got a little typo here, but other than that, I will let you finish this one. Work on C, D, and E/F. 3-70, write the equation of the line containing the points given in the table below. So there's 2 of these. I'm going to do one, and then for the other, I'll just say C 3-70. So we need a starting value. We need a slope. Let's pick 2 points, 3, 8 and 2, 5. To get the slope, we can call this point x1, y1. This is point number 1. So the x coordinate and y coordinate are called 1s, x1 and y1. And then for the other point, we'll call that point number 2. So this point goes x, y, and we'll call it x2, y2, referring to the fact that this is point 2. So the slope m equals y2 minus y1 over x2 minus x1. This is 5 minus 8 over x2 minus x1. That's 2 minus 3. -3 over -1. Oh, and a negative divided by negative is a positive, and 3 divided by 1 is 3. Okay, there's a couple ways you can do this. One way to do it is to just add a column 0. You could put 4 here. Since the slope is 3, this goes from 8 to 11. So 5 plus 3 is 8. 8 plus 3 is 11. What would 0 have to be? It would be 2, right? So b equals 2. But the other way you can get this number is plug in 3, leave b. So you can take the slope, pick a point, and let's plug it into y equals mx plus b. This is x, that's y. And let's see if we can get b equals 2 out of this. So plugging in 8 for y, 8 equals, m is 3, 3 times 3, and that's equal to b. Okay, so we're going to have 8 equals 9, plus b. And take away 9, that's going to be -1. Whoops, so something happened there. Let's see. Uh-oh. Skipped a number. Apologies. What's in between 0 and 2? That's 1. So I tried to be fancy and make a little shortcut, but I forgot to write 1. So if we follow this pattern again, growing by 3, 2 is at 5, 3 is at 8, that means 1 should be at 2, right? 2 plus 3 is 5. That also means that -1 is right there in the middle. B should be -1. Alright, so what's our answer? Y equals 3x minus 1. Okay, 372, here's the setup. Here's the function f of x. And here's the function g of x. Let's start with f of -5. Replace x with -5. That's 7 plus the absolute value of -5. When you take the absolute value, that's the number's distance from 0 on the number line. 5. Takes the number inside, makes it positive. And 7 plus 5 is 12. We're done. Let's try B. G of 4. Plug in 4 to this equation. We have 4 raised to the power 3 minus 5. 4 raised to the power 3, that's 4 times 4 times 4. And then we take away 5. If we consider PEMDAS, PEMDAS tells us to multiply first. We did the exponent, now we multiply. 4 times 4 times 4. Oh, use your calculator, people. That's 64, and 64 minus 5 is 59. One more, G, so we'll use the G function. Input -2, that's -2 to the power 3 minus 5. Any number raised to the power 3 means repeat that number, -2, 3 times. -2 times -2 times -2, then we're going to subtract 5. Now, -2 times -2, that's a positive 4. But we got to multiply it by another negative, a triple negative. A double negative is positive, but a triple negative, in the end, comes out negative. So -2 times -2 times -2 is just -8, subtract 5, and that's equal to -13. Use what you know about slope and y-intercept to graph this equation. Here's our starting value, here's our slope. The slope is negative, so we'll be going down 1 and over 2. Let's start by putting the y-intercept, or starting value, on the y-axis, 3. Then, what do? We go down 1 and to the right 2, negative slope. Down 1 and to the right 2. Down 1 and to the right 2. Down 1 and to the right 2, we're off the graph. $379, C3-70, I did that one. 381, use the rectangle ABCD at the right to rotate this rectangle 90 degrees counterclockwise. About the origin, to create rectangle A prime, B prime, C prime, D prime, name the coordinates of C. What you're going to want to do is use trace paper. We also call it patty, trace or patty paper. Alright, so B. Let's start alphabetical order. A, we're using patty paper, we're coming this way, 90 degrees. So, what is our final result? That's going to be A prime. Same with B. We're using our trace paper, patty paper. I can't really demonstrate that on the screen. There's B. Okay? So, this side of the rectangle comes down here. Then C, we're using patty paper, trace paper. There's C, and then just kind of process of elimination here. D has to be right there. Name the coordinates of C prime. C prime is going to be -5, -1. Now if you notice the original coordinates of C, it was -1, 5. So what happened? Rotation, x, y. It got sent to, reverse the order, y comes first, then x, but we need to make that y coordinate negative. So that's the shortcut for that one. Okay. One more, and then you can do C and D, so that area of a rectangle. Just count the number of squares. How many squares are in the rectangle? That's the area. B, reflect the rectangle ABCD across the vertical line x equals 1. Okay, so ABCD, it's referring to this original rectangle. Okay, and x equals 1, it's a vertical line, so go to the x-axis, find 1, and draw a vertical line. So it's got to be a mirror image on the other side. This looks like it's 2 units away from our line of reflection. B prime goes there, C prime goes here, and then we kind of redraw our rectangle like that. That's a mirror image or a reflection. And we only really care about the coordinates of C. I'm sorry, this is C double prime, B double prime, A flipped all the way over here, and D flipped all the way over here. C double prime is going to be 3, comma 5. (3-90). What is the area of each part of the entire rectangle at the right? Write the area. What is the area of the whole figure? Write the areas of the rectangle as a product and as a sum. Let's start with this rectangle. The area is length times width, x times x. X times x is x squared. X times x is x squared. X plus x is something else entirely. X plus x is 2x. We're not doing that here. We're multiplying. Area is length times width. So let's do another one. This one has a length of 8 and a width of x. 8 times x, 8x. Let's do another one. This one here has a length of x and it has a width of 3. 3 times x is 3x. Lastly, length of 8, length of 3. 8 times 3, length times width is 24. 8 times 3. Okay, so how many x's do we have? We have 8x, we have 3x, so we have a total of 11x. We have x squared plus 11x equals 24. Oops, not equals 24. We're just adding up all the areas in between. So x squared plus 11x plus 24. So this is what we call area as a sum. Area as a product is when you put each side in parentheses. So x plus 8 is our length. X plus 3 is our width. If you multiply length times the width, you should get equal the area as a sum. So that was the whole problem that time. And area as product is this one here. Area as sum is the expression on the right. 391, solve for the variable in each equation below. Show your work, check your solutions. All right, let's do it. I'll let you deal with these two. I'm going to do the one with the fractions. So this is 1/2 x. So the trick here is multiply by 2 on each side. So 2 times 1/2 x minus 2 times 37. And over here we have 2 times negative 84. 2 times 1/2, that's just 1x minus 2 times 37 is 74. Calculator, use your calculator. So the trick actually cancels out the fraction, turns it into 1x. And then 2 times 84 is 168. Use your calculator. And we're pretty much done. Add 74 to both sides. It's going to make that cancel. So x, 1x is just x. X is equal to, let's see, 168 minus 74. -94. Negative 94. Okay, so negative 168 plus 74. This number is bigger. The larger number carries the sign. So our answer is negative. And then the difference between the two is over here, 94. Oh, and there's one more with fractions. Let's do c. c, let's multiply each side by 4. All right, 3x times 4. To undo the division, we multiply. So it's to multiply both sides by 4. And remember, 4 is the same as 4 over 1. So this is 4 times 3x, which is 12x. It just multiplies the top. And on the bottom, it stays the same. And over here, we've got 4 times 6. That's 24 over 1. 1 times 7 is just 7. Now, 12x divided by 4. 12 divided by 4 is 3. So this is 3x equals 24 over 7. Okay, now divide both sides by 3. And x equals, when you're dividing the right side by 3, keep 24 over 7, change division to times, and flip. Keep change flip. 3 becomes 1 over 3. So this is 24 over 21. 92. For each expression below, write a simpler equivalent expression using only positive exponents. Okay, we're multiplying here. X squared times y cubed times x to the power negative 2 times y to the power negative 2. This is x to the power 2 times x to the power negative 2 times y to the power 3 times y to the power negative 2. I just rearranged them. And I did this because when you multiply two numbers that have the same base, the exponents have to add. Okay, so these 2 plus negative 2, right? That's x to the power 2 plus negative 2. And then we're going to have y to the power 3 plus negative 2. So that rule again is x to the power 5, x to the power 6. If you multiply two terms with the same base, then the exponents are going to add. 2 plus negative 2 is 0, so this is x to the power 0, y to the power 1. And any number to the power 0 is just 1. So that's 1 times y raised to the power 1. Raised to the power 1 is, you don't need to write it. Or just 1 times y, which is y. All right, part D. When I cube this expression, this whole thing is the base, and 3 tells me how many times to repeat the base. So it's 2x to the power negative 1 times 2x to the power negative 1 times 2x to the power negative 1. The base gets repeated 3 times. This is the base, and the exponent is 3. Now, it gets repeated, so let's multiply everything together. We have 2 times 2 times 2 times x to the power negative 1 times x to the power negative 1 times x to the power negative 1. 2 times 2 times 2 is 8. Times x times x times x is a single x. But again, this rule, if we multiply two x's, the exponents are going to add. So what do we get if we add all these together? Negative 3. And we have a negative exponent, so don't forget to cross the line and change the sign. X to the power negative 3 flips to 1 over x to the power 3. Final answer is 8 over x to the power 3. 393. Write and solve an equation to represent the given situation. Be sure to define your variable. Most people forget that. Samantha currently has $1,500 in the bank. That looks like a starting value. She is spending $35 a week. That looks like a negative growth. Her money is decreasing. How many weeks will it take until the account is only worth $915? We're supposed to write and solve an equation. So, if our starting value is $1,500 and our slope or growth is negative 35, let's plug these into y equals mx plus b. Right, the starting value or the y-intercept is how much she started with, and the slope or how much the account is growing, in this case decreasing, negative 35. So y equals negative 35x plus 1,500. All right, and let's say x, we need to define the variables. X is going to be equal to number of weeks. Right? Negative 35 times the number of weeks plus the starting value. So this will tell you how much she spent, or in how many weeks. So that means the other variable, the independent variable, is y. Y is money. So how many weeks will it take until her account is only worth 915? In other words, when y is 915, what is x? There's the equation. Plug it in. Solve for x. 94. Graph ABC with vertices A, 8, negative 4. B, 8, 1. And C, 2, 0. And this is a triangle symbol. So there's my triangle. What is the area? Well, this triangle, this is kind of our base. I'm thinking about the triangle like this. So our base has a distance of 5. And let's think about the area formula. Area equals 1/2 times base times height. So if you rotate the triangle upright, we have a base of 5 and a height. How tall is this? That would correspond to this line here. That's 1, 2, 3, 4, 5, 6. So it's going to be 6 units tall. So the area is 1/2 times the base times how tall it is, which is 6. So you kind of have to like rotate the triangle upright to be able to see this one, but that's how you do it. So we have 1/2 times 5 times 6. That's 1/2 times 30, and that's 15 units square. Don't forget to square your units because it's area. We've got 3 parts more. I'll do the first one. ABC is rotated about the origin 180 to become triangle A prime, B prime, C prime. Name the coordinates, the new coordinates. Use patty paper. Makes this a whole lot easier. Alright, so if we're using patty paper, we're rotating it 180 degrees, so it's going on the other side. So it's hard to show this on a computer, but using patty paper, C would come over to here. B would come all the way over here. And then A would come all the way up here, and that's going to be A prime, B prime, and C prime. Okay, so C prime is -2, 0. B prime is -8, -1. And then A prime is -8, 4. So you can see in comparison to the original, the X became negative and the Y also changed signs. X changed signs and Y changed sign. So the shortcut for this one is X, Y goes to -X, -Y. That's a shortcut for 180 degree rotation. And I'll let you work on this one. Be careful on this one. We're rotating it about a point C. So we're taking this original triangle. Now we're drawing our plus sign right there. And we're spinning it around this point. Versus before, we drew our plus sign on the origin. So be careful. Spin it around C. And let's look at 395. Graph the line on graph paper. Y equals 3/4 X plus 0. Plus 0. There's no starting value. So what that tells you right away is the starting value is 0, the origin. And the slope is positive. Positive 3 over positive 4. So up 3 over 4. Rise over run. Up 3 over 4. Draw a slope triangle. That's this thing. See graph. Rotate your slope triangle 90 degrees around the origin. Here's the origin. I'm drawing my plus sign there to get a new slope triangle. So this brings everything down 90 degrees. Let's go clockwise. All right, this point comes here, this point comes here, this point comes here. So whereas before we had rise of 3, run of 4, now we've got a rise of 4 and a run of 3. But this time, be careful, this line is going to be negative. So this is negative 4. So what happened? 3 over 4 became 4 over 3. It went upside down and opposite sign, opposite reciprocal. And I'll let you write the equation. That is it for today.